Here we'll look at solving equations with more than one variable, like this equation here, which has an a as well as a b. But first, let's look at an equation with just one variable. 5k minus 14 equals 3k. Try solving this equation for k, or click down here to review. Nicely done. There are a few different ways to solve this. First, you can add 14 to both sides. These 14s cancel, so 5k equals 3k plus 14. Then you can subtract 3k from both sides to cancel out the 3k over here. 5k minus 3k equals 2k, and so 2k equals 14, meaning k equals 7, the correct answer. Now let's return to the equation from the beginning. 15 plus 2a equals 4b plus 7. For equations with multiple variables, you might be asked to do something like this. Solve for a in terms of b. That means you should rearrange this equation so it says a equals something, where that something is an expression involving b. Let's figure this one out together. To get a by itself, we can subtract 15 from both sides. The 15s on the left cancel, and adding 7 and subtracting 15 is the same as subtracting 8. Then, to get rid of this coefficient, we can divide both sides by 2. These 2's cancel, and on the right we can distribute this division. 4b minus 8 all over 2 is the same as 4b over 2 minus 8 over 2. Now 4 over 2 is 2, and 8 over 2 is 4. So a equals 2b minus 4. So we've done it. We solved for a in terms of b. Try another example. Given the equation 12x minus 13 equals 3y plus 8, solve for y in terms of x. Excellent. So y equals 4x minus 7. And try another one. 4a plus 3 equals negative b plus 9. Solve for a in terms of b. And this time, the coefficients in your answer might be fractions. Nicely done. So a equals negative b plus 6 all over 4. An equivalent way to write this would be to split it into two fractions, negative b over 4 plus 6 over 4. And you can also simplify the 6 over 4 by factoring out a 2, so it equals 3 halves. And negative b over 4 is the same thing as negative 1 over 4 times b over 1. If you're not sure why, click down here to review multiplying fractions. And finally, b divided by 1 is the same thing as b. So here's yet another perfectly fine way to write the answer. Next, let's return to our original equation. You solved for a in terms of b. Can you solve for b in terms of a? Exactly. b equals negative 4a plus 6. Okay, so why are we solving for one variable in terms of another? Well, suppose I were to tell you that a equals 5. Then what must b equal? You can use either of these equations to figure it out, but you might find it easier to use this equation, where you already solved for b in terms of a. Right, you can plug 5 right into this equation. So b equals negative 4 times 5 plus 6, which means b equals negative 14. So that's why it's useful to solve for one variable in terms of another, so it's easier to see how the value of one affects the other. Let's look at another equation. X equals 6y minus 2x minus 9. And suppose you're asked to solve for x in terms of y. Well, you might be thinking, great, we've already solved for x. It's equal to 6y minus 2x minus 9. Our work here is done. But not so fast. Suppose you were told that y equals 7. Then what does x equal? Well, we can take 6y minus 2x minus 9 and plug in 7 for y. But this does not tell us what x equals because we still have an x in our expression. So this is no good. When we say solve for x in terms of y, we mean find an equation where x equals an expression that is only in terms of y. There should be no x's on the right side of this equation. So go ahead and solve for x. Very well done. You combined like terms and had all the x's on one side of the equation, and then you solved to find that x equals 2y minus 3. Now, if you were to plug in a value for y, this equation would quickly tell you what x equals. Try solving an equation with 3 variables. If 2a plus 4b plus 6c equals 0, solve for a in terms of b and c. Precisely, a equals negative 2b minus 3c. Okay, try solving one last equation. If 3xy equals 1, solve for y in terms of x. Right, to solve for y, you should divide both sides by 3x. On the left, the 3x's cancel out, so y equals 1 divided by 3x. So for your final challenge, again suppose that 3xy equals 1. If y equals 2, then what must x equal? In this lesson, we'll look at some unusual equations. But first, solve this one for p. 5p plus 18 equals 8p. Nicely done. One way to solve this is to subtract 5p from both sides. On the left, the 5p's cancel out. On the right, 8p minus 5p equals 3p. So 3p equals 18, and dividing both sides by 3, you found that p equals 6. Now take a look at this equation. X plus 4 equals x. For which value of x is this equation true? And if you're having trouble finding a solution, click down here. Yeah, there doesn't seem to be any solution for this equation. If we try to solve it, we can subtract x from both sides. So great, the x's on the left cancel out, leaving us with 4. But the x's on the right also cancel out, leaving us with just 0 on the right. And now the equation says 4 equals 0. We didn't solve for x at all. All we got is an equation that's just plain wrong. The truth is, you can't solve for x in this equation. Why not? Because for any value of x, the left side of this equation will always be 4 more than the right side. For example, if x is 3, then x plus 4 is 7, so the two sides are not equal. If we try making x 7, then x plus 4 is 11. Or we could try a negative number, like negative 2. Then x plus 4 is positive 2. No matter what value you try for x, you can never make this equation true. So you would say there's no solution to this equation. There's just no value of x that works. So next, take a look at these equations here. Which of these have no solution? This is a tricky question, so you'll want to examine each of these equations carefully. Excellent work! For this equation down here, the solution is c equals 0. And for this one, the solution is d equals 2. Meanwhile, these two equations up here have no solution. There's no value of a that could make 3a plus 8 equal 3a minus 5. And distributing the 4 over here, this becomes 4b minus 4. There's no value of b that could make 4b minus 4 equal 4b. Okay, so next we'll look at another unusual equation. X minus 2 equals x minus 2. See if you can find a solution for this equation. In other words, for what value of x does this side of the equation equal this side? So it turns out that any number would have worked. For example, if we let x equal 8, then both sides here are x minus 2 or 6. So because both sides are equal to each other, 8 is one solution to this equation. How about 2? If we let x equal 2, then both sides equal 2 minus 2 or 0. No matter what x equals, x minus 2 will always equal x minus 2. Both sides say exactly the same thing, so all numbers are solutions for this equation. Okay, here's your final challenge. Of these equations here, identify which of them have all numbers as their solutions. Again, look at each equation carefully. Nicely done. If we look at this equation up here, there's no value of a for which 2 minus a equals 3 minus a. So this equation has no solutions. Down here, this actually does have a solution, but it has exactly one solution. C equals -2. Meanwhile, all numbers are solutions for these equations. This bottom one says the same thing on both sides. And so does this one. If you distribute the 3, then you can see that both sides of this equation are 3b plus 6. So when you're solving equations that have a single variable, be careful. Many equations do have exactly one solution, but some equations don't have any solutions, and for others, every number is a solution.